Okay guys, we're going to spend some time today on Coulomb's law. I'm going to go into proportions as well as solving some problems, and I'm going to step you through both of these processes. So the first thing we're going to do, I'm going to look at just the proportion side of this, and these are questions 1 through 3 here at the top. So I'm going to go ahead and add the formula in, and then we're going to go from there. So the first thing, like I said, we're going to look at, I'm going to add in the formula. So we have FE equals KE Q1 Q2 divided by R squared. Remember that this is a force. These two are charges. This here is the R is the distance. And then K is just Coulomb's constant. So remember that this here is a constant. This is just a refresher from what we spoke about last class, okay? So I just kind of wanted to highlight that real quick before we get it too much into talking about this. So number 1 says, what happens to the force between two charges if the distance between them is quadrupled? So if the distance, we're looking here at the distance itself is quadrupled. So we need to know, how is F proportional to R, right? R is the distance. So F, or Fe, the force, is actually proportional, oops, sorry, let me take that back here, proportional to 1 divided by R squared. Okay, so we have F is proportional to 1 divided by R squared. What we're going to do is plug in how R is changing to that proportionality. So we have 1 divided by, and then what's happening to our R? Well, our distance is quadrupled. So quadrupled means 4 times. So our distance is going to be 4 squared. So then I'm going to reduce down this fraction, and I end up with 1 divided by 16. That means that what happens to the force between two charges if the distance is quadrupled? Well, our force is now 1/16. So force is 1/16 or 1/16 times. Okay? Now we're going to go on to number 2. And so number 2 says, what happens to the force between two charges if the distance is reduced 4 times? Okay, so if it's reduced 4 times, then this means that it's 1/4 of what it was originally. So again, we're starting with that proportionality. Fe is proportional to 1 divided by R squared. Okay, so we have 1 divided by, what happens to the R? The R is 1/4. Okay, so we have 1 divided by 4 squared. So again, we need to reduce. So this is going to give us 1 divided by 1/4 squared. You square the top and square the bottom, so that is 1/16. And then we have 1 divided by 1/16. Okay, so we have to get the fraction out of the bottom. So in order for us to do that, we have to multiply by the reciprocal on the top and the bottom. So we're going to have 16 over 1 multiplied on the bottom, and 16 over 1 on the top. So on the bottom, the 1/16 times 16 over 1 cancels out. So then we're left on the top with 1 times 16 over 1, and that is going to give us an answer of 16. Okay, so this equals 16. So now, if it says what happens to our force between two charges if the distance between them is reduced 4 times, it is now 16 times the force. Okay. Now we're moving on to question 3. Okay, a little bit different. It says what happens to the force between two charges if the magnitude of one charge is tripled? Okay, so we're talking about the magnitude. Magnitude is simply a number. Remember, we've talked about this. Magnitude is a number. Doesn't matter, positive or negative, of one charge being tripled. Okay, so one charge is tripled. So on the other side of this, we said F is proportional to 1 divided by r squared, but it's also proportional. So Fe is also proportional to Q1, charge 1. Fe is also proportional to Q2. So Fe is proportional to Q1. It's also proportional to Q2. Same thing what we did for the distance. You're going to plug in how the charge is changing into that proportionality. Okay, so Fe, right, we said it's proportional to one charge is being tripled. So we can say that charge 1, Q1, doesn't matter, Q1, Q2, same thing, is tripled. So 3 times, right? So we're going to plug in a 3 to that. Okay, so it's done. F is going to change by 3 times. So force changes. Force is now 3 times as much. Okay, doesn't matter what the force is, it's just 3 times as much. Once we plug it in, we're done. Okay, so now I'm going to take us down to the problems down below, and we're going to look at 3 different calculations about how to calculate our force using Coulomb's law and plugging in our values for charges and for distances. So of course I'm going to start with the formula as I always do, and then I'm going to plug those in for you. Okay, so we're starting with Fe equals Ke, remember Coulomb's constant, Q1 charge 1, Q2 charge 2, and r squared, which is the distance between them squared. So this is equal to, remember Coulomb's constant is 9 times 10 to the 9th. Okay, so we're going to start with that. 9 times 10 to the 9th times each of the charges. Well, they tell you that there are 2 particles. So 2 particles here. And each has a charge of 2.5. Okay, so charge 1 is 2.5 and charge 2 is 2.5. Nowhere did it say that they were different charges or that they were negative, so we're going to use positive numbers. Then they tell us it's separated by a distance of 10 meters, so we're going to divide by 10 squared. Remember, that's the distance squared. So I'm going to go ahead and plug this into the calculator. Remember to use your E function on your calculator. It saves so much trouble with order of operations and the times 10 button. So we do the second button and x to the negative 1, which gives us an E. So it should say 9e to the 9th times 2.5 times 2.5 divided by 10 squared. This gives us 5.625 times 10 to the 8th. And remember, this is a force, so it's in newtons. The other thing it asks is this attractive or repulsive? Well, each of our charges here, remember, they're right here. They're both positive numbers. So because they are the same sign, they are going to be repulsive. Remember, like repels like. Okay, next problem. Calculate the force between a 0.05 Coulomb charge and a 0.03 Coulomb charge 2 meters apart. So again, we're going to go ahead and start with Coulomb's law. Fe equals Ke Q1 Q2 divided by R squared. Oops. Okay, so we're starting, the Ke is 9 times 10 to the 9th times 0.05 and 0.03 divided by R squared. So that's 2 squared. Okay, so I'm going to go ahead and plug that into the calculator. 9e to the 9th times 0.05 times 0.03 equals divided by 2 squared. Okay, get 3.375 times 10 to the 6th. Remember, we're still calculating forces, so this is newtons, and this is repulsive. Again, we're looking at the two charges, and they are both positive, so they are repulsive. They're going to repel each other. Number 6 on here says the distance between a pair of negative 0.015 Coulomb charges is 0.92 meters. What is the force between them? And is it attractive or repulsive? Again, start with the formula, always. Ke Q1 Q2 divided by R squared. And this is going to be, once I start plugging it in, Ke is 9 times 10 to the 9th. And it tells you there's a pair, right, pair of negative charges. So that means that both charges are going to be negative. Negative 0.015 times negative 0.015. Okay, divided by our distance, which is 0.92 meters squared. And then I'm going to plug this into the calculator. So we have 9e to the 9th times negative 0.015 times negative 0.015 divided by 0.92 squared. My answer on the calculator is 2.39 times 10 to the 6th. Again, this is going to be a force, and it's in newtons. Forces are always in newtons. And is it attractive or repulsive? Okay, so this time we have two negative charges. So again, they're still like charges even though they're both negative, so it is going to be a repulsive charge. So all of our charges on this paper were repulsive. However, if you have a positive charge and a negative charge, then that would be an attractive charge, okay? So that's separate from here altogether. Just remember this as you're going back through. Hopefully this has helped you a little bit. And we will continue on in class today, and we'll go from there.